आज हम लोग मैकेनिकल प्रॉपर्टीज ऑफ सॉलिड्स के बारे में जानने की कोशिश करेंगे। इसमें बहुत सारे डेफिनेशन हैं, बहुत सारे टाइप्स हैं और सम फार्मूलाज हैं जहाँ पर हमें लॉजिक समझने की कोशिश करना होगा। तो फर्स्ट ऑफ ऑल यू नीड टू बी क्लियर कि चैप्टर नेम इज व्हाट मैकेनिकल प्रॉपर्टीज ऑफ सॉलिड्स। मतलब हम लोग सॉलिड्स के मैकेनिकल प्रॉपर्टीज के बारे में जानने की कोशिश करने वाले हैं इस लेक्चर। तो इससे स्टार्ट करेंगे डिफॉर्मिंग फोर्सेस से। डिफॉर्मिंग फोर्सेस, डिफॉर्मिंग फोर्स। फर्स्ट ऑफ ऑल यू आर क्रिस्टल क्लियर कि ये कुछ नहीं बस एक फोर्स है और यू कैन से दिस इज अ टाइप ऑफ फोर्स, दिस इज अ टाइप ऑफ फोर्स। यहाँ पर हमें समझने की कोशिश करना होगा कि डिफॉर्मिंग का मतलब क्या है। व्हाट इज द मीनिंग ऑफ डिफॉर्मिंग? व्हाट इज द मीनिंग ऑफ deforming? Yeah, we know that this is a force. We know that this is force. But what is the meaning of a deforming? What is the meaning of a deforming? I have PPT which I read during this lecture. So yes, still I will read. A force, we know this is force. A force which change body. When we will apply a force, then body will change itself. Is called as a deforming force. Whatever force you are applying, if a body is changing itself, it means whatever we applied force will be known as a deforming force. Okay, deforming force. Got it? So deforming force is what? This is a force. When force is applied on object, then object changes itself. Okay, this is known as deforming force. I think you are crystal clear. Now next we have elasticity. Elasticity. Try to understand. We got it about deforming force. This was not difficult to understand. Deforming force. Elasticity. Look, if you compare physics in the real, I would not say physics, but there are some words, work, elasticity. There are some work. If we compare with real life, then we will not get a exact result. Exact result. Even you know. Okay. So this is warning. I would say, you will observe that yes, in real life there is happening which is something else, and you are teaching us which is something else. So this is warning. It happens. It is happening. Yeah, work, definition of a work in the language of physics is a different from the real life. Okay, from the real life. So elasticity. I think marker is not working. Tell me what should be meaning or definition of elasticity according to you. According to you, what should be? Elasticity. Elasticity, which means the property of a body, a property of a body to regain its original configuration after removal of a deforming force. whatever we applied the deforming force, if we remove that force, then object is gaining its original shape. Then we will say yes, this object is elasticity. Okay, which type of object? Elasticity. If object is regaining its original shape after removal of deforming force, then we would say yes, this object is nothing but elasticity object. Just we are saying name of the object is what? Not name, but what kind of object? Elasticity object. Elasticity object. For example, balloon or rubber ball. Uh, there are a lot of, but right now in my mind those examples are not coming. I hope you have understood. First, this was our force, and this is our object, elasticity object. If we remove, okay, we applied a deforming force on the object. If we remove deforming force on the object, and object is regaining its original shape, we will say yes, this object is elasticity. That's it. Clear? That's it. But there is a limit. Limit is compulsory. Elasticity limit. If we cross the limit, then what will happen? It will not regain its original shape. This will happen if you cross the limit. Okay, if you cross, you are applying more force. This will be our limit. Okay, limit. Steel is more. We have an example. Steel. You know what is steel? Steel is a metal. So steel is more elastic than rubber. Try to understand. Steel is more elastic. Steel is more elastic than rubber. Rubber is also object. Steel is also object. But it is same. Steel is more elastic. Okay, steel is more elastic than rubber. Try to understand. Try to understand. Next we have plasticity. Plasticity. No tendency. Tendency to regain. No tendency to regain. It will not have that capacity. It says that I have no capacity to regain shape of object even after removal deforming force. Yeah, so this is another object. Here we saw elasticity object. Second is a plasticity object. So elasticity object is that object which can regain, which will regain its original shape even after removal of deforming force. Just opposite of this object is plasticity object. Okay, when we will remove deforming force, then there are some objects which will not regain its original shape. So this type of object, just we say yes, this is a plasticity object. That's it. Okay, that's it. For example, putty on wall, mud. These are examples of a plasticity. Now next, the particle life. Particle life. Nobody is perfectly elastic. In a real life, if you see in a real life, we say yes, there is a nobody which is a perfectly elasticity or plasticity. Just we assume in the language of physics, just we assume yes, this is elasticity, this is plasticity object. But in real life, when it comes to real life, we can't say yes, this object is a perfectly elasticity, this object is a perfectly plasticity. No, not a perfect. There is a nobody which is a perfectly elasticity or plasticity. Okay, enough. Now, behavior of a solids. Elastic behavior of a solids. Elastic behavior of a solids. Where a solid is a deformed, means we applied force, which is a deforming force. When a solid is a deformed, the atoms are displaced from their equilibrium. Means object was, I think object would be in a rest or will be moving with a constant velocity. This is meaning of equilibrium. So the atoms are displaced from equilibrium position, causing a change in interatomic distance. This is our first behavior of elastic solids objects. Clear? When force is removed, we know elastic is nothing but here we remove force, then it regains its original shape. Yeah, we know. So when force is removed, the body when force is removed, the body regains its original shape and size. We have seen already this. Yeah, but it is saying this is a behavior of elastic object. A spring ball model explains elastic behavior of a solids. Yes, yes, it is truth. A spring ball. When you will do practical with a spring ball, at the end you will get result which will be behavior of elastic solids. Elastic solids. Are you understanding? These were two behaviors, okay, of elastic solids. Now next we have the stronger, the interatomic forces. Means if interatomic forces are more stronger, then a smaller will be the displacement of atoms. If you are applying more forces, then you will see that the distance of atoms are small. The distance of atoms between them will be very small. When interatomic forces will be more strong, or you would say strong. Clear? Okay, clear. Now we have come to the topic which name is the stress. Stress. This is stress. This is represented by this symbol. It looks like 6, but no, this is not a 6 in the language of physics. Okay, this is how we represent stress. Stress. Clear? This is how we represent stress. So first we have the internal restoring force. Restoring force means object same. We can take an example of a spring. A spring is a best example of a restoring force. Yeah. So it is saying stress is nothing but the internal restoring force. Who will apply? Object will apply. Yeah, restoring force. When it happens, when object wants to gain its original shape by applying the restoring force. That's why this is applied by the object. That's why. Okay. So this is a force which is applied by the object just to gain its original shape, which is known as a restoring force. Okay. So the internal, remember, stress is nothing but the internal restoring force per unit cross sectional area is called stress. We have seen meaning of restoring force, but when it comes to stress, just we add restoring force to define stress. But there are some more words. There are some more words about it, which is internal restoring force per unit cross sectional area. Means here we will take area, okay. Then this will be known as stress, clear? Which means this stress will be our restoring force upon area. And as you know that this is a definition of stress, the internal, through this equation you can understand meaning of stress easily. The restoring force of the object per unit area, per unit, this I am talking about this area, restoring force upon area is a stress. Means here how much restoring force are being applied by the object on per unit area. This will give us stress. This will give us stress. You can write it in this way. This is our symbol of stress, and the symbol of restoring force will be nothing but Fr. R is a restoring and F is a force. For area, we can write just a letter, a capital letter. Got it? There is a condition. Condition is here A should be equal to 0, and Fr, which is the restoring force, should be equal to Fe. Got it? When it comes to unit, so unit is nothing but SI unit. This is nothing but Pascal, which is also m raised to power minus 2. This is the unit of stress. This is the unit of stress. Clear? Now let's move towards which is types of stress. Once we complete it, then strain will come. But right now our work is to complete the types of stress. Okay, this was the definition of stress. After this will come nothing but types of stress. One by one we will see. So first type of which is longitudinal stress. Longitudinal stress. From the word you will have to understand. From the word which is longitude. This is a stress. We know that stress word is added with a longitudinal, so that's why we can say confidently, yes, this is a stress. But what about longitudinal? Can we ignore longitudinal word? No. If you ignore, then you will face challenges. You will face problem because you don't know meaning of longitude. That's why it is a compulsory to know meaning of longitude. It says this is nothing but horizontal or vertical. Okay, horizontal or vertical. So definition for this will be the deforming force which we are discussing. The deforming force will be acting along the length of the body. For example, I I said horizontal and vertical. Yeah, horizontal or vertical. If object is like this, vertical, so our force, restoring force will be how? Like this, vertical. So deforming force which will be acting along the length of the body, like this. So this will be our restoring force. Okay, deforming force, no, not a restoring force. This the deforming force which will be acting along the length of the body. This is the length of the body, and along this body, whatever deforming force will be acting, this will be known as longitudinal force. Just understand, deforming force which is acting along the body. It can be, this body can be horizontal, can be vertical. It is a choice of object. Okay, it is a choice of object. Next point for this is longitudinal stress results. It will give you result in the change in the length of the body. Try to understand. This is going to provide result which will be nothing but in the change, means length, whatever will be change of the length of this object. This is what we will give in the change in the length of the body. Only you will get change in the length of the body when it comes to longitudinal stress. Let me erase this part because uh, so that we can write more things. Now again, we saw longitudinal uh, longitudinal stress. So it was saying here, I will provide a change in the length of the body, change in length of the body. That's it. Now there is a again we are going to see types of longitudinal stress, not the types of stress. Okay. So when it comes to two types of longitudinal, two types of longitudinal longitudinal stress. Longitudinal stress. First, which is tensile stress. Tensile stress. This is compulsory. Even I would say I can't ignore it at all. If we ignore, yes, we will not understand some points which will be related to this. So first, which is coming tensile stress, and second, which is nothing but compressive, which is nothing but compressive. Equation. Fr upon A. For tensile, we have this object. Look at this. Tensile means doesn't Tensile means doesn't, not doesn't. In this concept, in this context, not doesn't. Tensile we will take. It is saying the tensile stress is nothing but restoring force upon area. It can be written as Fe upon A, means force which is being applied on elasticity object. Force on elasticity object upon A. So this side we can see this is a force on elasticity, force on elasticity. Restoring forces in this direction. Restoring force of this object is in this direction. This is our force. F is our force, and restoring force is of object. So this is saying our tangential stress will be nothing but Fr upon A. That's it. Compress means here we were pulling the object, but now when we will push the object, what will happen? We will get this result, which is restoring force upon A. There are two types of force. In the first, we are pulling the object. In the second, we are pushing the object. This is pulling force, Fa. Even you can write Fa upon A or Fr upon A. From this equation, you will get tangential stress. Okay, tangential stress. When it comes to compressive, here we are just pushing. So our equation will be a restoring force upon area. This will provide nothing but compressive stress. Compressive stress. Okay. This was about tangential stress and compressive stress. These are two types of longitudinal stress. Okay. Longitudinal stress. There are two things that can happen, which is compressive or tangential, which means pulling the object. Now next, shearing or tangential stress, which is a second type of stress, not a second type of a longitudinal stress. Okay, we have completed two types of a longitudinal stress. Now we are going to see second type of stress, which is shearing or tangential stress. Try to understand. Shearing is equal to tangential. This is your choice. If you want to select a shearing stress, yeah, it's okay. If you want to take a tangential stress, still it's okay. Okay, both are not different. Both are same. Now let's try to understand meaning of this word. It is saying an initially object was like this on the earth, or you can say on the ground. But when force was applied on this object, then just base was same. Upper part of the body became like this. Base, after applying force on this object, base was same, but upper part of the body went in this direction. And this is what is the meaning of a shearing, or you can say tangential force. When you apply force like this tangential on this point, then what will happen? This object will go in this direction. Little bit, not too much. And even in the real life, it happens here. So this type of object, when force is being applied and their base is the same, but upper part of the body is a changed little bit, not too much, then this type of stress will be known as shearing or tangential stress. Clear? It arises from the shear force, the component of the force. component of the force. Here we will not take exact force. Exact force means resultant. We have this resultant force. Okay. So one component, if we are observing as one component of the force is being applied on this object, so yes, you will take only one component of the force, not two, not a resultant. Okay. If a resultant force is being applied, complete force, then you can take complete force. In short, you can say which one component is applying on the object. That's it. And whatever component force is applying, is acting on the object, just your work is to take that object. Okay, don't take unnecessary force. Now this type of sharing tangential stress says that this part we have to calculate this part. Initially object was like this, and finally object is like this. So this part, which this object covered this much distance, so this much distance we have to calculate. In this context, we would say what would be this much stress that force was applied. Okay, so simple formula is this is our displacement, yeah, and this is our length of the body, so distance upon length, yeah. So our sharing stress will be nothing but Ft upon A, or you can say Fe, which we applied. This is the force which we applied. Fe upon A. Okay. So sharing force is equal to Fe upon A. This will be known as our Fe, means force on the object upon area. Got it? This was our sharing or tangential stress. Sharing or tangential object. Now third type of stress, which is nothing but volumetric. Here we will observe what volume, yeah, volume, bulk, hydraulic stress. When the deforming force is what? Force which was applied on the object, and that object changed its state. That is what is a deforming force. When the deforming force or applied force on the object act from all the dimension. This is object, okay, or you can say this is beaker. When force was applied on this beaker, so all the part of this body has changed, all the parts of this body from all dimensions, resulting in the change of volume of object, then such stress is called volumetric stress. In the discussion of sharing or tangential stress, we saw that just upper part of the body was changing, but now we are understanding about volume, let me write volumetric or bulk stress. This is telling you when force will be applied on the object and all the dimension of the object are changing itself, then this will be known as bulk stress or a volumetric stress. Okay. Yeah, we can have all these three types of objects in real life. This one, and this is second, and first was longitudinal, where we saw compressive force, compressive stress, and tensile stress. But here bulk stress is simply saying that is force when you applied force and all the parts, all the dimension of object has changed completely. Then this will be our for example force like this. This is force. All the sides of the object F. What will happen? From we are applying all these sides only on this object. What will happen? Of course, this object will change its shape. Volume. Volume means a space. A space of the body will decrease. If you apply like this force, then volume of this object will decrease, resulting in the change of a volume of the object. Then such stress is called volumetric stress. Okay, just understand our equation will be nothing but volumetric stress, which is equal to F upon area. You are observing here, formula is the same. F R restoring force upon area, F A upon area, F A upon area. Formula is the same. Yeah. So this point, which is very easy for you to understand about it. Formula is the same. You don't need to remember this formula. Just you need to understand meaning of all these types of stress. First we saw stress, which was nothing but stress was saying internal restoring force of the object per unit area, which is known as stress. Then we saw types of. When it comes to formula, we know about four stress, which is known as same formula, Fr upon A. So Fr is the restoring force, A is the area of the object. Then we saw types of types of stress. First was longitudinal. Restoring force is along the body. This is a longitudinal. Formula is the same. Then we saw two types of longitudinal, which one was tensile stress and second was compressive. Tensile stress is nothing but here we apply force, which is a pulling force. Okay. Then we saw what compressive. Here we push the object. Compression means we push the object. That's it. Then second type of stress, which is nothing but shearing or tangential stress. This figure will give you clarity. Formula is it. So definition of it says that upper part of the body will change and base will be same, and just whatever distance it covered will be our covered, and length will be our shearing or tangential stress. Clear? Third is volumetric stress or bulk stress. It explains that all the parts of the body will change itself if you apply force. Then you will see that is all the parts, not all the upper part, even including base part, upper part, and all the parts of the body will change itself once you apply force. This was our volumetric stress. Clear? Formula is the same. F upon R. F is nothing but restoring force. A is the area. Now next we have question. Next question. These were three types of stress. Enough. And two types of longitudinal stress. Clear? Now let's see question. Question. The ratio of radii of two wires of some material is 2:1. Find if they are stretched. If they are stretched by the same force, force is the same. Force is the same. The ratio of stress will be. What is question saying? Question is saying the ratio of radius, the ratio of radius of two wires of some same material, not some. I think it should be same material. Material is same. Okay. Same material is 2:1. This is ratio of radius. We have material which is a wire. Find if they are stretched, means we are pulling. Okay, we will pull the object, the wire, by the same force. Force is same, means Newton would be same. The ratio of stress will be what? Ratio we have to find. Radius is given. Ratio of radius is 2:1, and it is asking ratio of stress. Ratio of stress. First of all, it is nothing but stress. This is question based on stress. So our formula would be stress is equal to FR upon A. FR upon A. Okay. There are two radius. How much? Area. So area F upon pi r square. There is a one wire like this. Here we know this area of this circle is nothing but pi r square. Okay, pi r square. And both sides we have pi r square. Force is the same. From this you can directly say that stress is directly proportional to F and stress is inversely proportional to R square. Am I correct? From this stress is inversely proportional to 1 upon R square. We know this thing we know. Okay, enough. This is providing two types of this is providing two ratio, and we have to calculate ratio of stress, and given thing is which is nothing but ratio of radius of the same material, same material. Of the same material. So here, this ratio we have to calculate 1 and secant. 1 and secant. So ratios are given upon a square, which will be equal to 1 upon 2. This is a 2 is to 1. So just we put this 2 in the place of R1 and in the place of R2 1. This was given thing by the question. Just simplify it, you will get 1 upon R. This is nothing but it is a ratio of stress, which is 1 upon 4. This is a ratio of 1 upon 4. Yeah, finally it's our answer. R1, not R1 but stress 1. Stress 1 is 1 and stress 2 is 4. And the term of ratio you can write like this 1 is to 4. This is our final answer.